Here we go. So this is, the question asks, how far apart are they after 4 hours? So I am looking for the distance. But the funky thing is they don't give you the distance of both boats. They actually give you a speed. If someone could remind me what the speed is. One was? Go ahead, Alan.
One's 12 kilometers per hour and the other
Okay.
15 kilometers per hour.
Right, and this is 15 kilometers per hour. So, evidently, obviously, distance would be in kilometers, but they give you speed. You can't use speed to calculate distance directly. There is some form of conversion that has to happen. So, method one, I have a feeling some people have an idea. Ewan?
Since you know the speed that's going per hour and you know how long they're going to be going, you can just multiply the speed by the time. So it would be 12 times 4.
Okay. So, simplify. So, again, simplify / convert speed to distance. That's method one. Long story short, if everyone recall this formula, speed is equal to, or velocity equals displacement over time, distance over time. Speed is equal to distance over time. And so if I give you the speed, which is 12, and I give you the time, which is 4 hours, you see the algebra? How do I get d all of them? How do you get rid of denominators? Every single. Getting the hang of it now? Algebra is not supposed to be hard. Okay, you see a division of 4, you multiply both sides by 4. Distance is 48 kilometers for the first boat. Do the exact same thing for the second one. V is equal to d over t. If I have 15 kilometers per hour and I travel for 4 hours, multiplying both sides by 4, I have 60. And all of a sudden we have distance, angle, side, angle, side. Cosine law.
Then you can do cosine.
Exactly. So just plug it in. If you're looking for distance, let's call this d. D squared is equal to 48 squared. 60 squared minus 2 times 48 times 60 times cosine of 80 degrees. Plug that all into the calculator. And I'll probably jump cut to the future. Now's a good time to take out your calculators and work through it with me. If you have an answer, amazing. Anyone have an answer?
Yeah, I do.
What is it?
4903.786.
Good. 786. I'm going to write as much as I can. Okay. And then I will round at the very end. The square root of whatever we just found would be approximately 70.0. 70.0.
What
Good.
does V stand for?
Pardon?
What does V stand for?
V, velocity, it's a
So what's
speed.
that?
Speed.
Speed?
You could say that's speed. I'm so used to writing velocity because, I've gone through the physics route. So speed is obsolete. Speed is old and it's dated. It's in the past. We talk about velocity because we are interested in this. You'll see if you do this, okay? Moving on. That's method one. Method two gets you to think a little bit more creatively. Method two asks you to entertain the thought of how quickly is the distance change. In other words, calculate the speed. Right? Use rate of change, aka, in this case, speed. So the idea is this: if you have that particular triangle, we know how fast this boat is moving, we know how fast that boat is moving. I'd like to know how fast is this distance increasing. In other words, if the speed of this is 12 kilometers per hour, the speed of this is 15 kilometers per hour, what is the speed of this dotted line growing by? long story short, do the same thing, but use 12 and 15. Don't worry about this. Just use it. If I know the speed of this and I know the speed of this, I should know the speed of that. Cosine law still applies. Yes?
So wait, so 70 kilometers is just saying what the distance is at that point?
So after 4 hours, remember, 4 hours have passed. The question told me. So I know in 4 hours this will be 48, and that will be 60.
Okay, so we just calculated it at 4 hours?
Yes.
And then now we're trying to find out.
So we're not even going to look at how many hours have passed yet. So take a look at what I did. Ready? The speed of the dotted line squared is equal to the speed of the first boat plus the speed of the second boat minus 2 times 12 times 15 cosine, and the 80 is still there because that's what the angle is between. Okay? So before we talk about distance to distance to distance, why can't we talk about speed to speed to speed if we're dealing with a triangle? It all works. Yes?
If we're trying to find the speed, couldn't we have just divided the 70 by 4?
Let's see exactly. Okay, so speed. So this is why I need you to think in multiple directions. This is growth, people. Okay, this is not memorizing what the teacher tells you. This is thinking for yourself. Someone's got to do this for me, or if you want to follow along.
It's 17.5.
Why did you have to write 0.0? Like 70.0?
That's a good question. If this was a science question, I would have to not give you that to have proper significant digits. But it happened to be 70.01 something, so I just rounded.
Okay.
It's 17.5.
This one?
Yeah.
Square rooted and all? Okay. So let me get the previous step. 2 times 12 times 15 times cosine. That becomes 306.486656. And so the speed is about, square root of that, 17.506763, which is about 17.5 kilometers per hour. In other words, this dotted line is increasing, is getting larger and larger by 17.5 kilometers every hour. Do those two answers disagree? Well, let's take a look at what that is in 4 hours. If speed is equal to distance over time,
That's 7 days.
17.5 is equal to distance after 4 hours. So what's distance?
It's 70.
Distance is equal to 17.5 times 4, which is about 70 kilometers. So we're talking about the exact same thing, but in 2 different methods, or 2 different units, or 2 different concepts. One is specifically talking about distance, the other one is talking about how quickly it's changing, but it's still the same triangle. Yes?
So, would we have to find both? Would we have to find the speed?
You don't have to do both.
Distance?
Specifically, the question asks for the distance. So this would give you the correct answer right away. However, what if the next question was, what's the distance in 5 hours? Right? If you did it this way, you'd have to turn this into what, times 5? This would be 60, that would be 75, and you have to calculate all that again, and you would get something else. But if you did it this way, because you know how quickly it's changing, you take 70.5 and you just change that to a 5, and you get your answer right away. So the difference between distance and the rate of change is, this is a very specific scenario, and this is, well, give me whatever scenario you want. I have a formula for you right now.